Well, okay, I think we'll get going. So welcome to the session on partnerships for protecting children. I'm John Zoltner. I'm the lead for technology for development at Save the Children. And I'm presenting along with two representatives of Omdena, who I'll ask to introduce themselves. Laura Clark Murray and Guneet Singh.
John, would you like me to introduce myself now?
Yes, please do.
Hi, everyone. I'm Laura Clark Murray. As John said, I'm with Omdena, and I'll be explaining a bit about Omdena. We're the technology partner who worked with John and Save the Children on the project that we'll be talking about. And I'm the Chief Operating Officer for Omdena. Looking forward to sharing more.
Cool. Hi, everyone. I'm Guneet Singh Kohli, and I'm a third-year undergrad student from India. So in partnership with Omdena, I was the junior ML engineer who worked on the project of Save the Children. And today I'm going to discuss about the project that we developed in the period of 2 months. And I'm looking forward to having a great discussion about it with you all. Thank you.
Thanks, Laura and Guneet. So I'm going to get started to talk a little bit about Save the Children and our commitment to the topic of protecting children online. And then we'll go into what our partnership is with Omdena, specifically this one project. So Save the Children has three main breakthrough goals that we're focused on through the entire organization across the world. One is to make sure that children survive. No children dies before their 5th birthday, because we know if a child can live to their 5th birthday, they're much more likely to thrive in the future. The other is to make sure that all children have access to education, because it's through a quality education that they can fully develop themselves. They can access educational opportunities and eventually livelihoods opportunities. And the third is that they're protected against violence. That's really the reason why Save the Children was initially founded about 101 years ago in the wake of World War I. So when we were founded, of course, digital technology didn't exist. But as the people we work with started to get access to digital technologies, we realized we needed to step up in that area. And really today, if we're not working in digital, then we're not protecting children. So for about 20 years, we've been active in this space. We do research, we train both government officials, parents, teachers, and children themselves on how to be safer. We run some hotlines for reporting images, sexualized images of children on the internet. And we provide psychosocial report for children that survive violence online. I just want to quickly give a description of what I'm talking about so we're on the same page. Child sexual abuse materials are many times referred to as child pornography. In this field, we use the term child sexual abuse materials, or CSAM, in order to underline the fact that it's always sexual abuse. It's not just a type of pornography. And CSAM, as we call it, is any kind of explicit photo, video, or other media of a child 18 years old or under that's depicted in a sexualized manner. But other examples of violence against children online are bullying, including sexualized comments about children and bullying. And then as part of this project, you'll hear more about Grooming, one of the methodologies that adults use to gain access to children is by grooming, where they're winning their trust somehow, usually through chats, by representing themselves as being something that they're not. This is a huge problem. It's grown, as you can see, 15,000% from between 2005 and 2020, and it's not slowing down. In fact, it's speeding up. So it's not a problem that's going to go away without tremendous concerted work across multiple types of organizations, the private sectors that run the technology platforms where this abuse happens, the nonprofit organizations that are dedicated to stopping it, governments, and all the other sectors that come together to try to stop online violence. What happened in 2020 is, in the midst of that tremendous geometric growth of online violence against children, we had COVID-19 hit. Children, about 90% of the world's children were displaced from their schools. A lot of the children we work with at Save the Children don't have access to digital technology, but a lot do. And those who do were suddenly much more at risk online. Use of the internet went up about 50% worldwide in countries where there's access. Children not only were moved, their classes were moved online, but they also spent much more time on online gaming, using social media, video chatting with their friends, because they were isolated. They were stuck home alone, and they needed ways to connect with other people. What happened also is that parents and caregivers have not been able to give the amount of attention they'd like to in order to make sure that children are safe and not accessing inappropriate content while they're using the internet. And the predators who are looking for children are also free at home. They're not bounded by the restrictions of corporate networks, so they can access content they wouldn't be able to access at work, and they have more time to do that and less supervision. So I'm going to stop sharing in order to more just have a conversation. So let me talk a little bit about how we met Omdena and got involved in this partnership. So I just described the environment that we're functioning in. So that's why we're so focused on online violence. We're focused on violence of all types against children, but as I showed, 15,000% growth is atrocious, and it's something that we're committed to working against. One day I received an email from my CEO forwarding me an email that the CEO of Omdena had sent to her, proposing that we work in a project together. I get these all the time. I get them directly to me. I get them forwarded from colleagues and sometimes from senior staff at Save the Children or other places. And a lot of times it just, they're kind of lost leaders trying to get us involved somehow in working with them in order to sell us services. In this case, I responded to her saying, hey, that's probably what it is, but I'll reach out to the person and then I'll see if there's any reason for us to connect. So I read the attachments that were in that original email, and I got kind of interested. So I set up an appointment. We did a video conference, and when I heard about how the Omdena model works, I realized that it's what we needed, because for a long time I wanted to work in applying data to explore the problem of online violence against children so that we can understand it better and create interventions in order to stop it, to prevent it, or to stop it when it's happening. So we talked one day. During that conversation, we kind of sketched out what it might look like. And again, that's something that happens all the time. We talk with companies or organizations about doing something together, and a lot of times nothing ever happens. In this case, later on the same day, I received a written description of what the project might look like. So I thought about, well, who at Save the Children should I go to in order to get interest and authorization to do that? And I decided things were moving so quickly that I'm just going to launch into doing it. So within 2 or 3 weeks, Omdena was recruiting volunteer data scientists for the project. And a couple weeks after that, we launched the project. Our project was a little different from most of the projects I work on because the goals were a little more open because we weren't really sure what data we could get. We run into a lot of times at Save the Children and other organizations I've been involved with where we have really capable companies, some of the world's largest tech companies sometimes come in and offer us free data analysis services. But our problem is we don't have the data together, we don't have it in the right format, we don't have enough data, it's not saved in the same place. So we're not able to just hand over the data in order for that company to do the analysis. So the Omdena partnership was different, where Omdena used artificial intelligence and used other data science techniques to really scour the internet, look for appropriate data that could shed light on these problems. And they scraped that data, put it into databases, cleaned it up so that they could actually use it to analyze, and so that we could make decisions about what our projects would look like. It happened really fast. It happened over the course of about 6 weeks, 6 or 8 weeks. And we got much more than I ever expected out of it. They divided into 9 task teams. Laura's going to talk a little bit more about the methodology they used to do that. And of course, some outputs were more valuable than others, but the one that is the most concrete and I think has the most potential to turn into a concrete tool that will help move this field forward is the anti-grooming chatbot, which Guneet will talk to later on. And this finally is, it's not a project that will just benefit Save the Children or Omdena. There's a large global network of organizations that work in this area. There are the nonprofit organizations that run the hotlines for reporting CSAM. There are other helplines for children that function to receive reports about any kind of violence against children, whether online or off. There are the companies that run the search engines like Google and Bing, or the platforms that host content like Facebook and Snapchat and Twitter, TikTok, who all those companies are gathered together in an organization or sort of association called the Technology Coalition. So we're able to consult them, and we're looking for ways to bring in those various partners in order to help us carry the work forward. So I'm going to pass over now to Laura and ask you, Laura, to talk more about in detail about the the Omdena process.
Okay, great. Thank you so much, John. I am going to share my presentation. Here we go. You're seeing my slides? Okay, I'm assuming you're seeing my slides there.
Yes.
Great. Thank you so much, John. It's great to hear the background story. For those of you who joined after I introduced myself, I'm Laura Clark Murray. I'm the Chief Operations Officer with Omdena. I'm really delighted to be here today to talk about the partnership that we had with Save the Children, or we still have with Save the Children, and the work that we did together. And I just want to start by saying, expressing gratitude to John and Save the Children for the opportunity to have worked on such an important problem. So I want to explain a little bit about who we are and how we go about things, and John did a great introduction there. We're a social enterprise, we're a business, and we're a collaborative platform to build innovative, ethical, and efficient AI solutions to real-world problems. So we were founded on a few key ideas. What if we brought together artificial intelligence experts, machine learning engineers, and data scientists from around the world to collaborate, work together on projects that really mattered to them, and give them an opportunity to do good work in this world? And what if we gave them a framework and tools in which their work could be self-directed? And what if we matched those teams of AI experts with people and organizations who are faced with tackling these big issues, organizations like Save the Children? And so that's what we've done. We created a platform for teams of diverse experts from around the globe to build AI solutions together to the important and challenging problems facing our world today, in partnership with the organizations who know most about those problems. So since we launched in May of 2019, we've executed on 43 projects. We're now currently going at a pace of launching one project a week. We've worked across many sectors with partners including UN agencies, NGOs, startups, foundations, and corporations. And we've brought together more than 1,700 of these AI and machine learning data scientists, experts, to collaborate in groups and teams of about 50 people for each project on our intensive 8-week projects. So the organizations that we partner with, you see a collection of them here. What benefits them is that, first of all, they're getting access to a team of let's say 40 to 60 experts, engineers, data scientists who are focused exclusively on their problem. And given the nature of the fact that people are all over the world, effectively the work is going on around the clock. It's really quite remarkable. Sometimes this gives an organization a head start into AI. They're very interested in AI. They have a problem they think is for which AI is very suitable, but they don't have a technology staff, or they have a small technology staff, or they don't have any data, and they feel that that might be a showstopper. We're often working with organizations who are in all of those categories. And they get the opportunity to address a problem that is real, that is not just abstract or in the lab. They get the opportunity to overcome these data challenges, to work with us to attempt to do that. And we're typically deploying prototypes and sometimes deployable solutions within that, within those 2 months. And often what comes out of this, as I think is partially the case in this project for Save the Children, is also a roadmap, a sense of what is possible to do with AI moving forward. So we look to the partner to bring the problem and the domain expertise, while we bring the machine learning engineers and the data scientists and this very evolved, refined framework in which everyone works together. So I'm just going to very quickly show you a few of the projects that we've done. For example, in the area of image analysis, for a lot of organizations, they could really make use of, let's say, high resolution satellite imagery, but that's very expensive, and it usually requires, a level of expertise in-house to know what to do with that data. So at Omdena, with many of our partners, we focused on actionable results without high-res images, properly processed and analyzed, and especially when used in conjunction with maybe more traditional data sets, we find that even low resolution and sparse data sets of imagery can offer invaluable insights to help solve problems, inform policy decisions, and help direct humanitarian efforts. Planning is is a sub area of AI that we've done quite a bit of work on. Typically, what those projects are about is finding some kind of course of action, procedural course of action for achieving goals while optimizing for performance. And we've worked with NGOs and large UN organizations and the World Food Program and others on projects such as this. And then natural language processing is an area we've done quite a bit of work, and natural language processing, or NLP, is using machines to read text, hear speech, interpret words. There have been fantastic advances in this technology over the years. And in many of these projects, as was the case with the Save the Children project, there's no actual data that we're starting with. The project is gathering the data through these NLP techniques. And so the data is compiled from publicly available text sources such as newspapers, government documents, and social media. And when I talk about the Save the Children project, hopefully that'll be a little more clear what I mean. And again, insights gleaned this way can often be used to supplement other data sources for a more complete picture. The way we work is quite different than standard development projects, and John kind of pointed to that. So our approach involves collaboration, diversity of the team, and bottom-up development. Those are the three main concepts. So within our framework, everyone works together regardless of their level of expertise. The team self-organizes into task groups to work on a portion of the problem that they find interesting, or for which they have some expertise, or they think they have a good idea. Any team member can create a subgroup and try out something new. Our partners provide the domain expertise, and they're collaborators themselves. So they're providing course correction as the work unfolds. They're right in there with us. On the diversity side of things, we've seen time and again the impact of bringing together people with vastly different professional and life experiences. Our teams are typically 30%, 35% or more female. On any given project, we'll have an average of 14 countries represented. Our collaborators have quite a range in age, as you see. And this diversity leads to sort of more trusted solutions and more ethical solutions, because all these different perspectives are kind of incorporated into the work that's being done. It also fosters a kind of creativity that you won't find when it's just a homogeneous group of people working in a single location in a lab. It's just by definition, people see the world differently. And what comes from that are alternative ideas about not only about how to solve problems, but also what data is relevant and where to find that data. And then the third piece of this that I mentioned is this idea of bottom-up development. So what do we mean by bottom-up development? Most development projects are done from the top down. The problem, you start with the problem and you break it up into a bunch of chunks and say, okay, we have to tackle all of these chunks. And then someone at the top tells others what to do, and the execution goes on from there. We take the opposite approach. Our projects are powered through this idea of bottom-up collaboration. So this is characterized by this open dialogue among all the team members, where diverse ideas are shared. Often multiple subgroups are working on the same problem, And what happens is that the best solution bubbles up to the top. They're all trying things and sharing the results of what they're doing. And by doing that, we have this sort of build, test, and learn mentality that incorporates feedback early on. The approaches that are working proceed, and those that don't are left behind, and then the team members come on and do new tasks and work on the other tasks that are happening. So now I'd like to just give an overview from the Omdena perspective of this project, this excellent project that we did with Save the Children. So as John mentioned, he came to Omdena with a broad problem area. You know, how might AI be used to understand the severity, causes, and actors of online violence against children? And how might we identify the behaviors of predators with the ultimate goal of preventing online violence against children? So we pulled together for this project a team of 43 collaborators from around the world. They represented 18 countries, of which 35% of the team was women. The team had our 8-week is the length of time. So they had 8 weeks to gather, to first of all, analyze that problem, take a look at that problem and figure out how they would approach it. Then to gather and build data sets, analyze and glean any insights, and then use the learnings to prototype tools with the potential to help protect children online. So this was primarily a natural language processing project. As John mentioned, the team organized and they self-organized into 9 key task groups to tackle the problem. And what I'm going to do is quickly walk through and give a summary of each major area before I hand off to Guneet to go into more technical detail on one of the areas. The first area, the goal of this group was to get a sense of the magnitude of online violence against children. And the team used natural language processing techniques to read and categorize articles from media outlets in 22 countries, many of which are considered to be hotspots for child sexual abuse material, like in the Philippines and Bangkok. The objective with this task area was to understand the behavior of both predators and victims. And natural language processing techniques were used to take a look at victim stories to see how do these situations unfold from the perspective of both the predator and the victim. And the team used material found in online forums and newspapers to do this data collection and analysis. They also used automated tools to craft a summarized library that could act as a safety data set, a collection of materials that could help to guide children to safety in these sorts of situations. And they categorized the material based on the intended audience, such as teachers, parents, and children. And this is now quite a significant data set of materials for Save the Children and, as John mentioned, for others to use. Another approach to this problem was to look at computer games. Online chat forums associated with certain computer games are believed to be or known to be a grooming tool of predators to reach children and to find victims. So using natural language processing along with risk prediction techniques and other machine learning techniques, the team built models to read game reviews. And based on that, they characterized the risk of tens of thousands of games. And then finally, I want to mention this overall area that the team also looked at. And the goal here was to gain insight on the language that characterizes an online predator's engagement with their child victims. Through analysis of conversations on social media and chat forums, they look to identify chat patterns and the underlying emotions of these chats, and they identified keywords. So they begin to build a model of what one of these conversations, these predator conversations look like. So what I was talking about there, these are all areas that the team, in groups within the team, looked at that overall problem, went out and figured out how to gather the data needed to address the objective, and they pulled together these very rich data sets. And those data sets and the accompanying analysis is quite valuable in and of itself, and John can actually speak to that, the value of that material. But the next step was then to take this further and to look out at how that data and how the insights gleaned from it might be used to recognize predatory behavior and educate children of danger, ultimately in real time. And so at this point, and so from that material, the team built some prototyped AI applications to aim to do just that. So at this point, I'd like to turn things over to Guneet Singh Kohli. He is an Omdena lead machine learning engineer. He's on this project, and he is going to now dive deeper into these prototype AI applications that the team created. Thank you very, very much.
Thank you, Laura, for the great presentation, and John as well for a great presentation about CSAM and the issues that Save the Children were looking at. So I'm Guneet Singh Kohli. I'm a lead ML engineer, as mentioned by Laura, with Omdena, and I'm going to present about the project, the chatbot, which is actually a prospective future product that can help in actually tackling this issue, which is creating menace around the world. So I'm going to share my screen soon. I hope everyone can see my screen. Hello?
Yes,
Yeah,
yes,
okay.
It's not in presentation mode yet.
Great. So yeah.
Excellent.
So the main issue that we began with was understanding the online violence against the children with AI. But as we discussed in the first week of our project with various collaborators, we thought that along with understanding the issue, there should be some kind of a method to counter it as well. So that was the basic idea that actually helped us in understanding this issue in depth and come up with an idea of countering it with the AI solution. Now, what kind of an AI solution we could come up with? The most important thing was that we needed a very robust and a dynamic system that could be integrated with any platform. Since the amount of chatting platforms that are available right now with our generation are humongous. There is Twitter, there is YouTube, there is Discord, there is Instagram, Facebook, and whatnot. So keeping that in mind, we came up with the idea. But to begin with, I should mention that it was an extremely ambitious project from our side, and to be completed in just a span of 2 months. And as you can see on my screen as well, such projects usually cost around $52,000 to $140,000, and also taking up a time span of about 1 year to just complete the first phase development. And remarkably, my team and I worked on more than 2,500 lines of code in Python, and due to the hard work and collaboration of 15 to 20 people over the span of 2 months, we were able to come up with this great idea. So this was our workflow that we had decided on. First thing, which was the most important thing, as even Laura has mentioned, was that it was to come up with the data. Now, we did not have a data to actually develop a kind of a chatbot. We needed a great length of chat logs that had taken place between victims and predators, which the bot could understand and actually mimic. So to begin with, we took around 1 to 2 weeks just gathering this data. So this was done through websites like Perverted Justice, which actually is a law enforcement website, which provides us with the chat logs that have taken place between victims and predators, as well as between police officers who disguise themselves as victim and converse with online pedophiles and predators so that they can nab them. So that was one of the greatest source for us, and we collected those chat logs. And the next task was, as you can see, dataset acquisition and pre-processing of data. We took around 3 weeks after that to just label and structure the data into the required format. And later you will see that it took almost more than 600 hours of man work to actually label it and structure it according to the need. We followed the basic chatbot approach and structured it according to a dataset of the Cornell movie dataset, which is quite famous in the field of NLP. The next task that was done parallelly while the pre-processing of the data was being done, we focused on modeling of the algorithm, which was sequence to sequence model, which is considered to be one of the state of the art in terms of chatbot creations. We worked on it, and most of the code was initially written in older version of TensorFlow, which later we are currently working to change it towards the newer versions. We then worked towards last 2 weeks. We worked on improving the model performances and even understand what all other things could be merged with this kind of a project so that it can be made scalable and as well as I would say, dynamic and robust. So I have a video presentation to show what kind of product we made. So I hope you can see my screen now.
There's no audio for it.
Oh, okay. I'll just check if I can share my audio. Sorry for the interruption.
I think we can even go ahead without audio if it's a problem to show it, because it does show the screens and maybe you can narrate.
I'm not able to get the option of sharing my. I'll just reshare once again if it's possible. Yeah. Sorry for the voice, but I'll explain it later. No issues.
Guneet, what are we seeing here?
Can you not see my screen?
Yes, but I'm just wondering if you could explain as we go along.
Okay. So this is a video demonstration of actually the project that we made. So the first thing you can see is how we structured the data using Microsoft Access, which was a database system. So you can see that we almost tagged around 800,000 messages into the right format. Along with that, we mapped the 172 dialogues along with the required format, which you can see right now. After this, I'll show you how the chatbot works. Currently, this shows the mapping of how we structured the dataset for the chatbot. This is some of the reference to the code that we made. So as you can see, there were like 2,500 lines of code that was involved in the chatbot creation. And this is a process of the training that we did. And it involved more than 7 to 8 hours of training every day for a week or so. And after that, we could come up with a proper chatbot that could actually mimic a predator conversation. Now, here you can see that the alpha kid is actually, you can see the victim, and chatbot is acting as a predator right now. you can see that the conversation is risky is a tagline that is actually evaluating each conversation tag coming from the predator. So once it evaluates those sentences, it labels it as risky or non-risky. And once it finds out if that the chat is becoming too risky for the victim or a child to continue, it will just shut down the system. So this was the basic idea. Sorry for the conversation. Sorry for the voice issue, but I'm going to discuss about it now. So as you can see that this was the data acquisition, and there was no structured data available to begin with, and 600 man hours were dedicated just to structure it properly. The modeling approaches used were deep learning NLP, which is the state-of-the-art models, along with the transformers like BERT, XLNet, which have just been released in the past 2 years. These were actually tried on to find out the best accurate model to tackle this issue. Now, the second part of the chatbot was, first thing was to mimic the conversation between the chatbot, between the predator and the child. The second thing was to actually analyze what kind of a conversation was happening. So for that, it was quite important for us to actually manually label those sentences. We went through the data set, analyzed each sentences and labeled it as 0, 1, or 2. 0 meant that the conversation sentence was not risky or not predatory at all. And 2 meant that it was highly risky and it should not be further continued. The conversation should be stopped at that moment only. So in that way, we tried to merge the chatbot code with the line risk analysis code to come up with the alpha kit and the chatbot conversation that you saw in the video. Now, this is the complete architecture of how our data is flowing through the system that we develop. So the first thing is the data pre-processing that is done into the dynamic system. As soon as you type something on the on the chat screen, this is processed and then tokenized, divided into words, fed into sequence to sequence model, which actually encodes it, process it, and decodes it to again put it into the assemble sequence to sequence output, which actually merges with the line risk analysis. So the warning system that you were saying comes up in the last portion of the framework. The framework provides with the chatbot ready output along with the risk analysis that was done simultaneously. This was the accuracy of the sentimental analysis or the risk analysis we achieved. More than 91% was done only for binary tags, which were like if the conversation is risky or non-risky. And the multi-class approach shows if this conversation is risky, or is it tending to risky, or is it completely risky. So in that sentence and in that way, the accuracy came out to be more than 80%, which is quite marvelous, keeping in mind the amount of data that we were able to tag in the given time span. The chatbot converses properly, as you could see in the video, and it was trying to groom the child in that. The sentiment found have been tested on various robust sentences which were not part of the data set as well. And the sentiment analysis also seemed to perform quite well. Now, coming to the future improvements and resources of what can be done with this project. The first thing is to convert the framework inner coding to TensorFlow 2. So the TensorFlow 1 is an older version of framework that we used for the creation of the chatbot. So TensorFlow 2, which was released 1 year back, is quite dynamic, and it includes many libraries that could help in actually optimizing our codes as well as making it faster and more accurate. The second thing is like continuing to build up those PJ dataset. So the thing was that we were able to tag and structure more than 8 lakh lines of messages. But to structure it according to the chatbot model, we could only do around 10,000 lines of messages. So keeping that in mind, with over the period of time, we need to take this 10,000 lines to actual number of messages, that is 8 lakh lines of messages. So to do that, we actually are working still on this project, and we are trying to label it as much as possible. The third thing, which is the use of transfer training, which is the newer techniques that are coming up in the field of NLP, which talks about the use of premeditated weights that are trained on different kind of a data set, and that being used for proper tokenization and word alignment in the chatbot. And the final thing that one of the most important thing that we need to work on is to actually come up with a kind of an algorithm to confirm risk of a particular sentence along with the context. So there are examples like which many of the bigger organizations are also facing issues with, is like you can write a one standalone statement, but that one standalone statement might be not risky if it is taken into account with the context of the previous messages you were having with that person. But if we take into account a single sentence and it seems risky, then that kind of creates a confusion for the model as well. So to determine a proper flow of conversations and a risk analysis to be done, we need to take into account the previous context of the sentence that and the conversation that was going on with that person. So in that way, we don't want to label or stop someone who is actually having a normal conversation in a different kind of a sense. So these are some of the research we are still working on. So again, coming to the current work. So now the next step for us was to actually review the existing systems that were prevalent in fighting against CSAM. The first and one of the most famous one is the Thorn's anti-grooming toolkit. So this is a technique that scans text-based chats for possible grooming and allowing individual companies to monitor potential grooming and report it to law enforcement. The second one is Google's Perspective API, which, as you can see, helps us in recognizing and labeling a kind of an attribute, which can be comments, messages, any kind of a discussion as toxic or non-toxic. Now, as you can see, these two ideas can be taken as two different separate areas that are targeting CSAM. But what our idea was to actually merge these kind of ideas into one. So the flow of the conversation in a kind of a chatbot environment would be that consider I'm a child talking to a predator. Once I type sentences and I'm having a conversation with them, the chatbot will be monitoring my sentences. Now, the best part of it is that we are trying to make it a locally available software. So that way your chat won't be leaked outside, as well as it can monitor any kind of sentence or any kind of a platform through your laptop or your system. So in that way, if I'm having a conversation and if the chatbot finds the conversation is now tending towards a predatory system or a grooming phase of the conversation, the chatbot will start sending me the notifications of the risky analysis. As you could see, the warning messages that were coming with the alpha kit. Those warning messages will be counted, which is our initial approach. Like it will count the number of warning messages. If it crosses a threshold, the system will switch off the conversation and would shift towards the chatbot. The chatbot will now become active, and the point will be that the predator will be cut off from the child, and the chatbot will start having conversation with the child at that moment. In that way, the first step can be done is that we'll separate the predator from the actual victim. The second thing that the chatbot that we are hoping that we can work on that system is that we can send the required notification to the parent or the guardian that they can check on what kind of a conversation was happening, and they could save their child at the right time and the right moment. Along with that, the chatbot would be made efficient enough to actually label that person and report it to the law enforcement at that moment only. So in that way, we want to have a local based system that can actually monitor your conversations and can actually safeguard your children at the right time and the right places. So this was the project, and this is the workflow that is being carried out. Thank you. Any questions? I'll be more than welcome the questions. Any questions you have regarding the project and all.
Thanks, Guneet. Why don't Laura, you and Guneet, let's all turn our cameras on, and Guneet, you can stop sharing, and we're open for any questions. As Guneet says, I think one of the things to think about with this project is that it never would have happened without a private NGO and private company partnership. Save the Children doesn't have enough technology resources, and especially resources and use of artificial intelligence, in order to engage in a project like this. And Omdena doesn't have the subject matter expertise. So we were very involved in, as Laura said, shaping the project and providing guidance over the course of the project. And Omdena, we were in constant contact because we were on a Slack chat that was literally 24 hours per day during the 8 weeks, because people who were working on the project lived all over the world. So that's really one of the key issues that made the project work. And just another, adding on to what Guneet said, we are now building on to products and talking to organizations that are also partners or potential partners from different sectors, so that Thorn anti-grooming kit that Guneet mentioned was a result of a hackathon that was sponsored by Microsoft a couple of years ago, that a lot of those primary hotline operators that I mentioned earlier, like NCMEC and Internet Watch Foundation, were at that hackathon. It was managed by Hani Farid, who's an important researcher in this area, an engineer affiliated with the University of Berkeley. So it took people from all different sectors to come together and do this, and we're continuing to work together.